we have a given root of binary search tree, and we have to find the k that we have given, right? So in the two sum, let me give you some hint, and you can say idea how to make a two sum problem, right? So in the two sum problem, like we used to given a some elements, right? Let's suppose we have 2, 3, 4, 5 and 6. Okay, so this is a array elements, and we have some elements we have given x to find, right? So let's suppose x we have given is 9. Okay, so what we used to do, we have to find this with the help of two sum. Means two sum means we have to use two element of the array, and then we have to make it x. Means x is nothing but 4 plus 5, right? So in this case, what is the index of the 4? Means index is 0, 1, 2, 3 and 4. So in this case 2 and 3 will be the output, right? So you can go through the two sum problem and you can see, you can try, right? So in this problem, what we used to do, actually we have given x is a target, right? So we used to find the complement first. Like we used to find 9. Let's suppose we have 9, so 9 minus 2 we used to do. 9 minus 2 is nothing but 7, right? We will find the 7 in the array. If we will find the sum in the array, it means this index and the 7th index, right? If we have 7 here, let's suppose, so this index are the value. If this 7 is not there, then we will move to the next element, and we have to find k is 9, right? Means we have to find the element. If elements are we have, then we will make the sum, and we'll say if it is exist, we will return true or false. See here, we will return true if there exist two elements in the binary search tree and its sum is equal to k. Means we have 9 we have given, this is nothing but sum, so we have to find the elements here. If any elements, let's suppose we have in this case 5 we have and 4 we have. Here we have 5 and here we have 4, right? So in this case the value is we should return the element. Similarly, another element we have got 3 and 6 we have given. So what we can do, we can say 9 is, we can make what, 3 plus 6. Another way is what, we have 2 we have given and 7 we have given. So we can say what, 2 plus 7 we can say, right? It's 9. So in this way we already have these elements. We can say, yeah, the elements are there, we can make the sum and it will give you a correct output x, right? Like this. Now you understand the problem, right? We have to find the element x with the help of sum, right? So how we are going to search the element? Let's suppose we have k we have given here, right? K is nothing but 9. So if we will find the complement is nothing but 9 we have given, the first node value we have given, right? Root dot val will get 5, right? So we get what, 4. So now we have to find 4 in this whole node, right? So what we'll have to do, first we'll check this 4. If 4 is less than 5, means this is a binary search tree, so we have to go to the left subtree here. So let's understand first. So we have given the element, let's suppose find target, let's suppose we have given, so we have given root we have given and the search element we have given. So this k should be the sum of two nodes value in the BST, right? So I have created another function that is called find, right? In the find, this is nothing but your root element, right? Another is the current node we are saying, and this is nothing but our search element, right? This is not the search element, this is the k value, right? That we will make. So finally what we will do, we'll say the current is equal to null, will return false as usual, I told you, right? Then we will make a complement k minus current dot val that we have already done. Means you can say 9 minus 5 is nothing but 4, right? So like that we will make a complement. Now what we have to do, we have to check if the complement exists in the tree, excluding the current node. We are not going to find the current node. See, in the last written code, what we are doing, we are not thinking about the current node, right? So current node we don't need to check, right? We have to exclude that node, right? In that case, we have to use the search BST root current node and the complement element. If this will return the element, right? It means it will return true, then we'll say return true. Otherwise we have to find this element in the left side and the right side, whichever will give you true or false, right? In the left subtree, in the right subtree, we'll check. If it will give you the k value things, means either it is in the left subtree or either in the right subtree. So similar kind of function will call again here as a, you can say, subtree. So this recursive call we have to make actually. Okay, so search you have to do, but search you have to also do in the left side and the right side. Okay, so coming back to here, in the search BST, we have already done what? Root k, right? And the current value is not, we have to exclude the current node, right? So we will say exclude node and then int k, right? We don't want to go in the node where we will have the element or not, right? Either we have to exclude left subtree or right subtree, but we have to see, right, that we have seen. In the search BST we have already discussed, so either you can understand this one or let me tell you. So we'll check root is null, return false. If not, root is not exclude node, or you can say root is root value at root value is equal to x, means we have got the search will return true, right? Means it should not be current element, current node value should not be there, because we have already made complement, right? So we'll say root dot val is equal to x and then we return true. Similarly, what we will do, we'll check for the root val is less than x, then we will go to the right one. If it is not, we'll go to the left one, right? And we'll continue this searching in the entire subtrees, like left subtree, right, seeds, children subtrees, right? Like that we will do. I hope you understand this problem, right? So basically what we are doing here, we have created a find method to make recursive call, right? So find we have written here, back to here, and we are excluding the current node, right? So we'll find the search, then we will do searching of the BST, right? Again, if we will not find on that current node, right, then we'll go to the left subtree and the right subtree. Either of one will return true or false, then it is true. And this is your search part. Okay, so I hope you understand this problem. So let's optimize this problem, how we are going to optimize the code. So if you, the basic thing you have already done, right, like implementation you have done, then the interviewer may say optimize this code if the time is left, right? So how we are going to optimize, right? So we will create a set of integer, right? If root is null, will return false. Otherwise what we will do, we'll check in the set, it our complement is at the set, it means we will return true, right? Otherwise what we will do, we will add root value on the set. So actually what we are doing, we are putting all the you can say node value on the hash set, right? And we'll check the complement. If complement exists in the set, it means it is we will return true, else will return false. Okay, so only the optimization thing is here, we'll take a set and will return the true or false element, right? So it is very easy problem.